All right.
So what
So
do
I'll
you
just, yeah, go
really
ahead.
think about DeepSeek? I'm also wanting to get an update from the US side on what is, yeah, what are your thoughts?
DeepSeek, yeah, it's a huge drama that has been going on right ever since 2 weeks. And I tried it on Friday. To be
Yeah,
honest, the first impressions were bad, but I think that was also my problem where apparently I had to turn on those toggles at the bottom of the chat window to search web, because I was
yeah,
trying to search web without that and I didn't even know. And neither the app or window told me that you need to turn that on to search on the web. So that is some UX problem. We are in experimentation, so we know
yeah,
about that now. But apart from that, I've still tried to get it to complete some of the work that I typically use Claude for, and
yeah,
it has never worked well for me. But I keep seeing all the reports online that it's amazing. It generates output so well that it's like Claude and OpenAI, like ChatGPT killer. But to be honest, I have never got it to work for my use cases. So
yeah,
I keep going back immediately to Claude to get my work done or whatever I have to do. I think one of the novel idea in that is it actually clearly shows out the thinking process, right? The thought process. It's
yeah,
loudly thinking everything, which is what most people are excited about. When I pasted in some things, even the loud thinking was completely off. Like what I pasted in, I gave it images. It was
yeah,
able to scrape some information of those images, but not everything, and it went into completely wrong territory, and it didn't
yeah,
achieve the task that I gave it to. So anyways, so that was one observation. Overall, yes, there are so many conspiracies going on. The model itself, like, it was just trained for 5 million, but no one knows that if that's the truth or not. I know on
yeah,
Wikipedia there is a 5 million amount for their base version, which is the V3 model, but
yeah,
no one knows yet about the R1 model. And now, I think since yesterday evening, there are more rumors that are saying that Microsoft has alerted OpenAI that their model was used to train DeepSeek's model. So they've basically gotten hold of OpenAI's base model and just trained DeepSeek on top of that. So, and Reddit is a huge cesspool of rumors, anyway. So some people over there are saying maybe that's why there are so many instances where it gets confused itself with as a chat GPT. So, and there are
oh, it confuses
screenshots out there.
itself.
Yeah,
Oh,
and there are
interesting.
screenshots out there where it
Yeah,
does say that it's chat GPT. Everything
but
is up in the
yeah,
air right now. Yes, the first Monday, like, yeah, on the Monday itself, right, day before yesterday, the stock market had tanked, and I was
yeah,
just with my friend on Saturday evening, and I was telling him like this deep seek is, I've tried it, even though it didn't work well for me. I feel
yeah,
that Monday it's going to be a bloodbath in the stock market, and that's
yeah,
exactly how it panned out. Because on Sunday I was reading more and more about that $5 million cost, and everyone was going to panic. So,
yeah,
but that day, so many people bought more Nvidia because that created like a buying opportunity with 17% drop in the
yeah,
stock price, and then next day it was up like 8%. Ultimately, many people are saying is Jevons paradox, which I had heard long time ago
yeah,
in road infrastructure
yeah,
related behavioral studies,
yeah,
where any city's road expansion project, when it happens, the purpose is to ease the traffic, right? That's why
yeah,
you expand the road. But then
yeah.
ultimately the problem is the more efficient the roads are, the more people move in, and then again it creates bottlenecks
The
everywhere.
same bottleneck.
So it is Jevons paradox. Like if you ease up the traffic, it's not
Yeah,
necessarily it's gonna stay that way forever. It will still get congested as more people come in and use that resources. So that's exactly what Jevons paradox in this way they were talking about is, as people realize that if DeepSeek has figured out a way to train the model more efficiently or
yeah,
make use of NVIDIA chips more efficiently, then it's gonna not tank its stock market. In fact, more companies are gonna realize that it's more cheaper to buy cheaper versions of NVIDIA chips and not go for
yeah,
the most expensive ones, and actually themselves jump into model training and stuff like that to and generate even more demand for their products. So that's Jevons paradox for NVIDIA. And that's how all the discussions are happening. But yeah, ultimately nowadays people are switching their backend model from OpenAI APIs
yeah,
to DeepSeek because it's extremely cheap. Firstly, it's open source, so you can just
yeah,
download the 670 billion model, billion parameter model onto your local instance and then just run it offline, everything it will
Yeah.
work. The cost of using it is super cheap, 10x cheaper or some number cheaper, but it's like few cents compared to a dollar, yeah, in Chat GPT. So yeah, 10x, 20x cheaper, something like that for execution. So that's why people are switching their APIs from OpenAI to um, uh, DeepSeek's
DeepSeek.
APIs. It
So
still does
wasn't
not
it?
affect technically NVIDIA, right? Because
Yeah.
OpenAI is it will affect OpenAI's revenue. Ultimately, they may not order as many NVIDIAs as well, but overall immediate hit to revenue would be for OpenAI, not to NVIDIA's. That's what my guess is. Sorry, go ahead. You were asking a question.
I was wanting to ask, even Llama had that capability that you can run it on your local machine, right?
Yeah, you can learn Llama on your local machine. Yes, actually nowadays there are so many models that you can run on your open machine on your local machines. You just
Yeah.
go to Olama website, you install that package for Olama 2, and then from there on their website you can see all of the models that are listed, including DeepSeek, and there are smaller
Yeah.
versions of the larger models as well, distilled
Yeah.
versions of the models as well, that you can just copy paste straight into your terminal and execute with Olama, and boom, it starts working in your terminal. So
That's
it's that
very
easy now. Yeah, it's just like 2 3 lines you have to write and done, it starts working on your local machine. The only problem is the UX in the terminal is so bad, right? It's not going to be
yeah.
clean output the way it shows up on the web or chat version, I mean the app versions. So that's why I don't prefer using it unless you
Yeah.
have a use case to build an app through a Python script or whatever, by
Yeah.
calling those into your code. That's a different use case. And there are so many tutorials out there that helps you create various types of apps using these different models as well.
Yeah.
So yeah. But anyways,
No, so I had a friend who told me this, and he's also running a Gen AI company, and his prediction was that just like SMSs, like when they came out, they were very costly, but it just fell down and like exponential drop. So he just believed that all intelligence will probably get democratized and it'll
yeah.
just reduce down to SMSs. Like every hit would be just as cheap as it gets. What will start mattering is what vertical that you build over it and how well do you solve the vertical. I think that is also part of the discussion that's going on.
Cool. All right. Let's get into the episode. Hello, and welcome to my very first episode of the podcast called
Yeah.
Variance, where just like a good experiment design, I will control for all the factors except for amazing variety of guests and the quality of conversations that we are going to have on this podcast. So I will host guests from experimentation and data science world because that is where I have spent almost 10 years of my life. And I have met some of the most awesome people in this space uh, through LinkedIn. And I intend to talk to them and just learn more from them about their perspectives, not just in experimentation, but also overall data science career as well as any career in general. All right. So in the first episode, I have Ishan Goel. Ishan was previous associate head of data science. He was leading data science research at VWO, which is acronym for Visual Website Optimizer. It is a very popular third-party experimentation platform, and Ishan has helped build VWO's new stats engine and enhanced its reporting system. Ishan is currently based in New Delhi, India, and he has a passion for writing and speaking about variety of topics, I'm guessing, and you will get to know more about it throughout our conversation in this podcast as well. Ishan has recently moved out of VWO and is now planning to launch his own experimentation course. And being in the same industry, I used to follow Ishan's work through VWO's tech blog, which I have read some of the articles, and I knew Ishan by name through those blogs, but not until very recently, like pretty much, if you want to say, literally beginning of 2025, is where I stumbled upon your webinars, and then it prompted me to just reach out to you and just have a conversation about these topics. So, welcome Ishan to Variance, and thank you for agreeing to be my first ever guest on the podcast. So, it's definitely gonna be special.
Thanks so much for that lovely introduction, Pritul. I would also like to highlight to our audience it was a very lovely surprise to be meeting Pritul, and I have already learned a bunch of things from him. So it is quite amazing to know a fellow statistician who has worked in the same domain. So thank you, thanks a lot for arranging this podcast, and it is definitely a pleasure to be here talking to you.
Yeah, no, thank you. Again, it's late on your end as well, so we will try to definitely wrap up as soon as possible, but definitely have great conversation before we
Definitely,
wrap up. And like all of our viewers would definitely want to see the side of you in which you typically we don't express ourselves or through either LinkedIn medium or webinars or whatever, right? And
yeah,
there's untold stories that have shaped our own careers that may inspire other people to
yeah.
towards their data journey. So hopefully we are able to capture some of those insights from this podcast for the viewers. All right. So yeah, we met about we also met on a Zoom couple like last week, and there I got to learn a bit more about you. You told me that you were a graduate of computer science, but then you transitioned into primarily data science. And
Yeah,
I told you I would love to know about that backstory, what exactly prompted you to do that switch, and we can
yeah.
talk about that maybe later. And today is the a great time where basically I would love to know like what prompted you to switch from computer science to data science, because that question boils in so many young grads who are either graduating in computer science and wanting to switch to data science or vice versa, right? So that transition itself, how did that come about,
Yeah.
and what advice would you give to the grads or young professionals in today's environment, given that Gen AI is kind of replacing data scientists? So
So interestingly for me, it was a very interesting and I would say a very rocky journey for that matter. I started off, I did my computer science engineering, BTech in computer science in Delhi. And then there I did a lot of coding, and surprisingly, I realized that I was good with coding. And statistics also was something that I had enjoyed even high school, elementary statistics, and even in college, whatever courses I took, I enjoyed them in statistics. But when I got into the job of coding and programming and stuff, and I realized that once you figure out how to solve a problem, then the whole part that is the 80% of job in software engineering to code it out. At least at that time, it just like I was sort of I and my friend used to talk about that. Once we figure out how a problem is to be solved, then we used to find it very hard to just write down the code to solve the actual problem. So it was a fun job. I think I learned structured thinking in it. But then I was very, very curious, and data science was coming up as a buzzword at that time. And even I knew someone who was working in the US who had done his master's from North Carolina State University only. And he had gotten into data science. So he was telling me one day on some sort of a prediction problem on what you do about it. And it was like sort of a Titanic data set and very primitive prediction problem for that time. And I really sort of found it interesting in the sense because I already liked statistics, and people were telling that data science is going to be the best job in the coming years, to be very honest. So that's when I thought I'll switch into it, but it was very hard to actually switch into it because at that time when you do not have any credentials and you are trying to find some work to do, it is very hard to find any work to do. So it's sort of like the chicken and egg problem. You don't have the experience, so you're not getting the job. You
yeah.
are not getting the job, so you're not getting the experience. So the hard part I think that I did at that time was I worked pro bono with a scientist for 1.5 years, where what I was doing, and I think personally, like when you leave your job and then you are working without money, it creates a sustained stressor on its own where you have to work hard and learn things. So I think that really
Right.
worked out for me in that 1.5 years that I really learned statistics with him. And this guy had some very interesting ideas in causal inference.
Okay.
So I think if you aim for a very high problem, then you tend to learn the easy stuff fast.
Right.
So yeah, so that's where I learned the basics of data science, then moved on to doing a job. For 1 year, I very honestly, I was working in a stock market company trying to write a prediction algorithm that can predict, but I was not able to do anything there. It was just a very hard problem. And then I moved to VW, and suddenly all that I had learned it started to
Right.
come in shape. And in the first 2 weeks, I had made something. I'd made their stats engine almost 100x faster. So a lot of things started coming together. So that
Oh
was
wow.
my journey. So yeah.
Two follow-up questions. What year was it when you stumbled upon data science? Rough estimate?
Yeah, it was 2016.
2016. Okay. So not too far, just 9 years ago, roughly. And how did you find the professor to get your pro bono experience?
Yeah, so it's very interesting. I met my father connected him to me just through out of like he would connect me through some opportunities that he would get. So he was in his network, and if you want to work for free, you end up like people just take you. And once you, so my father just told me that I'll pay you your basic pocket money for an year or so, and if you want to work with this guy, you work with this guy. So it was, I would say, serendipity that happened. And
Okay.
that guy really like I think he instilled the discipline in me to learn, if not other things. But yeah, it was quite good.
Okay, yeah, that's cool. So through networking, you got that opportunity,
But yeah,
even though the network was your father's network, but
yeah,
still, it helped. Cool.
yeah,
And yeah, so for the other half, like, what advice would you give to young grads? Like right now, it's so hard to even get a basic job in their own field, like of
yeah,
graduation, because of Gen AI buzz and every company just laying people off and not even like they want to replace the junior data scientist or junior engineer with AI. And Meta is working on building like AI, right, which can replace mid-level engineer as well now. So
yeah,
and then someone else is working on replacing the staff engineer or the senior engineer or a
yeah.
data scientist job. So I don't know anything about how well they are on that journey, but the one example I do want to give is Devin. Have you heard of Devin?
No,
uh,
Devin is
so
a
it
website builder, right?
no so Devin was it's an AI, it's an automated
Yeah.
software engineer, and it was announced last year with a huge hype. And late last year, they also launched a paid version of it, which is about $500 per month subscription for enterprise. And
Yeah,
that's the only plan they have, no cheaper plan.
yeah,
And there was a recent news article, like just last week, that I read is the AI software engineer is bungling vast majority of its tasks that it's asked to do. So
yeah.
it's just not able to complete any of its tasks in vast majority of the situation. So I don't know all this AI hype that's going on about replacing people with AI. How real it is, or is the bubble gonna burst soon of all of that? So just wanted to learn, like, get your perspective, and then what advice for young folks who are basically trying to get a job.
So I personally think that firstly, I what needs to be highlighted with AI is that we are definitely at the brink of change, and especially I think at the change of how we study and how we work and the different kind of jobs that are going to be. But I personally think that it's very hard to predict what will change and in what way will it change. Like, for instance, I think even some people have started talking about that the job of the software engineer will start to get eliminated. But on the other side, I also saw a post recently that people who are using AI to code extensively, they do not understand their own code bases well enough. So when a problem strikes, it actually becomes a huge mess without having
Right.
a person. So I personally think that it's very hard, even though it's very certain that a lot of changes are going to play out. It is very hard to predict that this job will survive or this job will not survive, because I think all jobs are under the scrutiny of going massive change and in different ways. So I personally find it futile, sort of, to optimize for the highest paying job 10 years down the line. I think what is
Yeah.
more important is that people who are currently in their learning frame, they firstly they learn to learn and they learn to learn fast, sort of. I think because
Yeah.
if you learn to learn fast, you are able to pivot quickly, and with the changing times, I think that will become the norm. That you pivot quickly and new jobs keep coming up, and then you study through courses and then you sort of try out new roles. Apart from that, I personally feel that. I feel that this trend of optimizing for the highest paying job, I think it has always existed, but it is sort of an ideal. I think one should not optimize for the highest paying job. They should optimize for a stable livelihood. And
Yeah.
then I think it's very uncertain on top of it. So I think if you're enjoying your work and you're doing it consistently, you'll anyways be better off than anyone who is doing their work with half their mind in it. So I personally feel that data science might go a massive change, and the traditional jobs that we are seeing in this age might not exist 5 to 10 years down the line. But the skills for learning complicated things that you'll get by learning data science will essentially help you out in other places as well. So yeah, I think the larger advice should be to sort of de-link this hard funnel between what you study and what you do. I think the reality is what you study might be very different from what you do 5 years down the line.
Yeah, that's true.
So
And pretty much same with me and many other people, right? Where I did my master's in something else and my undergrad in something else, and then I got into data field about five
yeah,
years later, like especially in big tech. So yeah, it was about a 5 year gap in between, but that is where I was mostly strengthening my core data skills. So now you said you already, I mean, I saw your profile on LinkedIn and you already had bachelor's and then you worked for quite a while before you opted to do your master's. So what actually
yeah,
prompted you to actually pursue that master's? I think you alluded to it a little bit in the previous question, but so what alluded to actually do that master, pursue your master's, and um, have you observed your ways of working after your master's and before your master's? Like, have you observed any huge difference in terms of your understanding of the work or the variety of problems or how to even approach a problem?
yeah. So I personally think, firstly, my primary reasons. I started thinking about doing a master's in 2016, 17, and I finally got to doing it in 2019, sort of. So I think the reason why I first made up my mind to do a master's was because I, honestly saying, I think I wanted to spend a few years in the US. And that's where I think a lot of people from my college and a lot of people doing research in data science were. At that time, the scene of data science was not very strong in India. And it seemed like if you are in India, you'll be getting a lot of grunt work and a lot of those things. And the real good work is getting done in the US. So part of the reason was that. The other part of the reason was I really felt that for a data science role, I really need a few years of hardcore research experience and some formal education more over a bachelor's to be really well versed with science. I think both of those of my reasons turned out to be false and untrue. I think neither was India in a shape where data science research was. I got a really good data science research opportunity at BW. And secondly, I think in the process of going to masters, I had done enough research that I was actually had gotten very adept with the research. So before going to my masters, 6 months before that, I had joined BW for the first time.
Okay.
And even in those 6 months, we were doing some very interesting research in personalization and stuff. So I think that was the thing. But why that goal of masters actually helped me is because I think when you aim higher, you have to make such big jumps that the lower levels of the battles get settled out very easily. So that's why I never regret spending that money and going to do my masters to the US. In terms of research and my work style, I would say that definitely over time, you linearly get a better work ethic and work system essentially. So like one thing that I learned in my masters from my research professor was journaling. So he was a Japanese guy, and what he would do is that every day, whatever work you do, you have a notebook of daily and you just write down whatever you found and everything. And I think that is the one thing. If in my whole of masters, I would not even look at courses. Courses were good, but that is something that I could have learned on YouTube and everywhere else also. But I think one was the direct student experience of living in the US. It teaches you a lot because you are hard pressed from all sides, and I think
Yeah.
that's a very great place to be in at that point in time. And secondly, I think if we talk about ethics, then one thing that I brought out from it was the journaling ethic, which has stayed with me till date, and it really governs how I work. So yeah,
Yeah, that's impressive. Um, yeah, that's a great point that you can actually learn everything online these days, but
yeah,
there are things that happen behind the scene that really help you grow that doesn't happen just by watching YouTube videos. It's happens by observing someone else's working style,
Yeah.
and just taking inspiration from that. So yeah, that's definitely a great insight.
I think personally the University of Hard Knocks, like there's this term my father uses that one needs to study in the University of Hard Knocks. So I think really for an immigrant, US education is very fruitful because more than what you study in the university, you are out of
Yeah,
your cushy
your work
life from
zone.
India, and then
Yeah,
you cook your own food and everything. So you tend to get a
right.
lot more disciplined there. So
Right, right. Yeah, absolutely.
yeah,
Yeah, thanks for that great insight. So you already alluded to like you got into VWO before your master 6 months. So how did you stumble into that opportunity? Like
in
basically that's your first exposure to experimentation, I'm guessing. No, you already were working with a causal inference researcher. So yeah, so just tell us like what was your first encounter with experimentation?
So interestingly, I'll tell you, my first encounter with experimentation was something very interesting. So when I went to this researcher guy, this statistics guy, I first researched with him. He told me something that has stayed with me till date. What he told me was that suppose you have two sine waves, A and B is exactly the inverse of A. So one A goes like this, and B goes like this,
Hmm.
and you add them up to get C.
Hmm.
So C will be like a flat wave. But C is directly causally linked to A and B because A plus B is equal to C. He says that no amount of correlation that you draw between C and C and B can tell you that these two are causally linked. But if you strip out the noise from A and you strip out the noise from B, because they are just random fluctuations on top, and then you correlate the noise in A and noise in C, you'll get a very high correlation. And when you do that, you almost get a very strong 0.7 correlation. So his idea was that can we use noise to actually construct back cause and effect from observational data or not? So that was a very, very interesting problem, and we researched a lot into it. That really forced me to learn a lot about cause and effect and a lot
Yeah.
about confounding and all these structures. So I think I learned it sort of top down. Like I learned the harder stuff first, and
Yeah.
then I published a paper in that domain, and then I moved out to some
Mm.
other domain. And then 2 years later, I just happened to join VW just because I was looking for a job, and VW was doing some interesting research. So I joined it, and then I realized, oh, I'm back in experimentation again. And I think for the first 3 4 months, I did not even realize that this domain and the causal inference domain are actually linked. So that's how I really got into experimentation. And then
Right.
we
And
started. Yeah.
I guess having your journal papers out there probably helped you get the VWO opportunity, right?
It partly did, but my papers were like I had written an interesting paper, but it was very, very niched out sort of. So it did show up on my resume and stuff, but I think what mattered
Right.
more was just my general data science knowledge and all those
Okay.
things.
VWO is a third party platform and
Yeah.
we have many, many customers who are using it to set up their A/B tests, right? So, as a data scientist on the platform team, what has been your perspective about the adoption of experimentation and A/B testing? A/B testing is easy to understand, but then experimentation is not only A/B testing. It's so much more. As you explained, it's also causal inference. What is your perspective, like in terms of adoption of other advanced methods outside of
Yeah.
the top companies that who actually have large scale research teams, but yeah, into other companies who cannot afford to have any of that. They just have to use a third party platform because it's the easiest solution out there.
Yeah. So I personally think that firstly, I think it comes in three phases, sort of. So the first phase is because A/B testing as a wrapper, it seems very simple. Like when I first heard about A/B testing, it seemed like such a natural idea that you show 50% of people A and you show 50% of people B, and then you can just compare. So it seems like a very straightforward idea, and it seems like, and I think that is common to everything in science, that at first it seemed very simple that this is something that you can do very easily. So I think you start off with that idea that from a statistics angle, it seems like a very straightforward thing, and that's what even the science behind randomized control trials claim. So on that front, I personally feel that all the platforms have done a very great job at democratizing this very esoteric scientific practice to a large part of the population, because they do not need to worry about data collection. They do not need to worry about a lot of these underlying statistics and stuff. It's sort of like a one click button, and like you can set up an A/B test in 15 minutes using such a platform. So I think they have done a very good job at removing all frictions from that first level of adoption where you start to test. But I think personally, there is this second phase that all scientists and probably scientists and statisticians sort of they go into when they really realize that experimentation might seem straightforward from the outside, but when you move inside, you realize that it's really like a messy job to cut your way through randomness, and how many false winners people get, and how many insights. Like, people will get an insight wherever they see a pattern. If you supply people with enough data,
Yeah.
they will. And I think that's what we did when we created constellations and astrology out of stars. I think we were given with so much pattern, so much data, that we were bound to find some patterns in it. So I think, but once you realize that how much of, like, I think A/B testing at the core, it's very experimentation at the core is very sophisticated, and I think that it has there are a lot of ways to go wrong with experimentation. So there is, I think, a very second layer phase where people definitely start feeling that the promise of A/B testing, as it looks like on the wrapper, it's not really that easy inside. And from there, I think people funnel down into two parts. There are those who give up experimentation for the sheer cost of it, and I think they start experimenting not formally but intuitively. All entrepreneurs are somewhere trying out ideas and constantly. And I think that final phase is where, once you realize that it is going to be a messy job, and there is randomness in data, and there are a lot of heuristics and things that you need to know and understand to actually effectively experiment, then I think that phase has been reached by a lesser number of people in experimentation.
Yeah.
But yeah, I think that's somewhere all these platforms and stuff cannot do a lot. It is up to people to learn all those scientific and statistical concepts and stuff, and to cultures of organizations as well. So yeah,
Right. And in
that
your
is.
role, did you have to, I'm guessing you had to work with a lot of customers as well?
So interestingly, the role was initially not customer facing.
Okay.
So what we were doing was, it was a small team, and we would be three people sitting inside a conference room and just talking about equations and statistics and various things that, like, the whole rest of the company would just would not even want to understand. And we would be three people. Then basically what we were doing was, with the founder of VW, Paris. He was supervising our team, so every week we would have a meeting with him, and for his perspective was very amazing. He had a very scientific first principle sort of a way, so he would scrutinize every simulation that we bring to him for, and would extract out, like essentially all the insights on, or all the questions that we hadn't thought of. So at first it was purely a research role, and then we started writing some very large scale simulations and stuff, like, sort of, we started simulating thousands of A/B tests in a very fast matrix format of a way. So it got very exciting at that point, where we would think of a solution, then simulate maybe a million A/B tests with different changing parameters and summarize them into a graph. So it was a very heavily research focused role. Over the next later half of that role, the later 2 years, I started talking to a lot of customers. One thing that I realized, and especially from a vendor perspective, is that people run AA tests. And so basically, like, if 1,000 people are using a VWO, then if say 100 people run an AA test, and out of those 10 get a winner, those 10 suddenly lose all trust in the tool entirely.
Oh, wow.
Because
Yeah. Yeah, true. Yeah, that
uh,
brings memories
yeah,
to me as well.
I think it's a huge problem. And like, even in AA tests, very honestly, I am in support of doing AA tests, even though
Yeah.
sometimes they do give winners. I think the real thing is that when you do stumble upon a data issue, and as a vendor, it is just there are sometimes you have data issues for multiple reasons. And generally, my advice with AA test would be to run the test again in a very few certain scenarios. Like, once there was a case where iPhone had some protocol installed in some iOS version of theirs that was causing some segment of the test users to actually be biased in variation or something. Something was off. I do
Mhm.
not remember exactly. And oh God, it is a very, very notoriously hard thing to debug when you
Yeah.
actually see a data issue. But that also, I think, that gives a flavor of how what is the real complexity of experimentation inside.
Yeah.
Like it is messy work. It is really, really messy
Yeah.
work. What I really find interesting about the distinction between an engineer's work and a scientist's work is that an engineer, like suppose someone is coding a website, they have a direct feedback loop that whenever there is an error, like if I make an error, there will be some error in rendering on anything. Something will break. The system will tell me that something is wrong. Whereas
Yeah.
when you think about a scientist's work, this back edge where you get to know that what you did was wrong might be even 50 years in the future or maybe 100 years in the future. You have
Yeah.
no way at all to know if what you did, like you run an experiment, the whole process will work fine, you'll get a p-value, you'll get a conclusion. The whole
Yeah.
process will not even hint out to you that you did something wrong when you have
Yeah.
done something wrong. So I think that is the real complexity of science, I would say, in general, and that is the real complexity of experimentation as well. And there is no way to get around it. Like,
Right.
and it has
Yeah.
always
True.
been so. So yeah,
True. True. Absolutely true. All right. So
yeah,
let's switch gears a little bit. I have
definitely,
something planned for us. Just
yeah,
very few questions, rapid fire questions. It's mostly this or that kind of questions, and
yeah,
I just want to know your pick on each of them. All right.
yeah.
So we'll go through this pretty quickly, beginning with the first one: Bayesian or frequentist?
That's a very interesting question, and it has been asked from me a lot of times. The practical advice is that they work the same. If I have to choose one, I really believe in the Bayesian promise that will actually, if we can control the false discovery rates, I think the Bayesian question is what really matters in science. And so, yes, I would pick out Bayesian, if nothing for the ease of interpretation. I think even if they perform the same, I think, and even if both are equally bad at controlling false discovery rates, then also I would want to pick the Bayesian one because it's easier to interpret rather than
Okay.
the complicated p-values. So yeah,
Cool. I would like to learn more about that aspect because I am a hardcore frequentist.
frequent.
Uh,
Yeah,
but yeah, we'll definitely talk about that in some later sessions or offline.
definitely.
Cool. The next
Yeah,
one,
yeah.
Python or R?
I have only coded in Python, so I cannot
Python.
like
Okay.
I'm
Yeah,
naturally
because
biased.
why I asked this is R was much more uh, like deeply ingrained into research community even before Python arrived, and I see
Yeah,
it even today. Lots and lots of researchers actually publish their work in R. I am
yeah,
following a few creators on LinkedIn who are in causal inference space, like they are econometricians. They are working on their books and stuff, and they are publishing R code and not actually Python code. So that's why I thought, as you being a researcher, what is your preference? But Python, yeah, I mean, I've used R once before. I could never
yeah,
get my head wrapped around it, so I found Python much easier as well.
yeah. I think if you
Oh,
come
sorry.
from a computer science sort of a background, then
Oh,
Python
yeah,
is
true.
much more. Yeah.
True, true. You came from computer science to data science, so yeah, makes sense. The next one is early stopping or fixed duration.
I think fixed duration is more robust, but because the most pressing problem for modern experimenters is the number of visitors you have, early stopping with a
Yeah,
properly installed sequential testing framework
cool.
is much better. I think it
Okay.
saves you a lot of visitors for that matter. What is your
Hypo-
preference on that?
I mean, same like you. As you said,
Yeah,
mostly the implementation is easier for fixed duration in large scale, and then
yeah,
if you do have a early stop, if the metrics go sideways or negative, then it's better to have some early stopping mechanism in place instead of a fixed duration so that you are limiting your losses. And as a
yeah.
result, as you said, sequential test could be well utilized in those cases. Yeah, I think it's the same pretty much for both of us on that one. Cool. The next one is in the hypothesis design, right? Do you prefer one tailed or two tailed hypothesis?
I think two-tailed has. So, firstly, I would want to highlight the difference. I've realized that the only difference is either if you are working on just a winning recommendation or you are also working on a disabled recommendation. Otherwise, I think the difference between one-tailed and two-tailed does not matter. It's only if you're taking the decision on both sides. I think a disable recommendation is very, very helpful if implemented correctly. Like if you are actually waiting for the metric to go become worse, that will happen very rarely, because most experiments, the change does not impact the target metric. But
Yeah.
if you sort of implement it with a shifted null hypothesis, where I've realized that a lot of these zero uplift cases get flagged early and you are able
Mm.
to disable early, that I think is a very powerful functionality, because then you are able to eliminate a lot of things that are not working very quickly. So that gives you the power to create 4 or 5 versions of your ideas and then test it quickly, like without expanding your
Yeah.
visitor requirement very much. So yeah.
Right. Right. Okay.
So that's
Cool.
why I would prefer two-tailed. So yeah.
Okay. Yeah. Yeah. I
Yeah.
mean, and also it's simpler to implement because
Yeah.
everyone is in learning mode, and it promotes learning mode rather than come with a confirmation bias and see something else on
Yeah.
the board and then go on to like a tangent accusing that the experimentation platform is weird or whatnot, right? So uh,
Yeah.
so two-sided, two-tailed test when you're training people to come up with a hypothesis, you're just telling them you don't know the
Yeah.
outcome of your alternate hypothesis. So you're just looking for, is it going to go positive or negative? And I guess it just promotes that learning slash exploration culture instead of just coming with a specific direction. And then when that doesn't happen, then that's a good way to control that side of behavior from the experimenter's perspective. So yeah.
Yeah.
The next one is Bonferroni correction or BNH procedure, which is both control different things, but which one would
Yeah.
you prefer?
I think so. Firstly, I think the easier one is Bonferroni.
Yeah.
BNH is a very, very beautiful idea. We actually did a very thorough research, because we were very, very doubtful that without having priors, how is it able to control FDR? So we did a very thorough research on how it is working. I think it is an amazingly beautiful idea. But the promise of BNH is, I think it is a little like you are not able to control the false discovery rates across the test. You are only able to control them inside a test.
Inside the test. Yeah.
So, where I personally feel that, like, if you have multiple variations, then you are able to control that. It is good for that purpose, but I just feel that its promise essentially that you are able to control false discovery rates, it's misstated. Otherwise, I think for that matter, Bonferroni correction is very straightforward that way. You don't need priors or anything of that sort. Uh,
Yeah.
but yeah, I would definitely say BNH is a much more beautiful solution for whatever it does. And the fact that it is also more relaxed than Bonferroni correction. Bonferroni correction just does tie out things much more tightly.
Right.
So,
Yeah.
but BNH has downsides. BNH does not, you cannot calculate sample sizes in advance.
Yeah.
You cannot do a lot of things that you can do in a simple Bonferroni style framework. So yeah.
Right. The next one is p value or confidence intervals.
So I personally, firstly, I read about that debate that a lot of people are saying that move away from p-values to confidence intervals. There were some articles.
Mhm.
I
Yeah.
think they're translatable. They're directly translatable. So it's like just two ways of looking at the same thing. And if you are more of a visual person, you can see a confidence interval and whether it is going out of zero or not. That is more easy. But if you want to reduce number, even p-value does the same thing.
Yeah.
So I do not have a exact preference, although I always tend to follow significance p-values over confidence intervals. But I think one very important thing when we talk about peaking is that a lot of solutions do not correct for sort of the confidence interval. They only correct for sort of the statistical significance. So there one should take care of it. Confidence intervals should also be corrected
Yes.
according to peaking. So yeah.
Right. Right. Makes
So yeah.
sense. The next one is most underrated statistical concept.
Most underrated statistical concept. Let me think for a minute. Let me think. I personally think I find this one idea very interesting. And I think it goes out for even all practical economists and stuff, that we have sort of summarized everything into the normal distribution because it's so versatile. And the normal distribution seems to be very intuitive to our understanding. But a lot of variables in real life, they sort of have fat tailed
Yeah.
ends. And these variables, like for instance, if you think about the number of impressions you get on a LinkedIn post, sort of it if you calculate all the LinkedIn posts in the world and you calculate its mean, and you plot this histogram, it won't be anywhere like the bell curve. It won't actually fit any fixed distribution. In fact, if you take all the LinkedIn posts, you plot its mean, and then you just remove the top five posts with the maximum impression. You're just
It's
with those
huge.
five posts being removed, your mean will change drastically.
Yeah. Yeah.
So what I think, there's this guy Nassim Nicholas Taleb. He says that there are two kinds of variables. One is the mediocre stan type variables. The mediocre stan variables are like variables like height, variables like how much food do you have in a day, probably, or things that do follow the normal distribution. They do not deviate a lot. But then there
Mm.
are these other kind of variables, which are the extremist stan variables, which come to dominate a lot of these real world processes. And these extremist stan variables are just chaotic, and as chaotic as they get. So a lot of these variables related to money, uh, even engagement and all these things, these are extremist stan variables with a lot of very high variance. And we are often experimenting with these very high variance variables. They
Right.
tend to escape all laws of statistics, all guarantees of statistics and stuff. I think the world needs to understand these extremist stan variables much better. So yeah.
Right. Cool. Next one is most overused KPI in experimentation. Like, is there a KPI that you've dealt with every other company just using the same KPI to optimize? And what is that?
So I think from my perspective, for the longest time at VWO, the only two KPIs that we were supporting was conversion rate and revenue per visitor. So from that perspective, and not having worked on the applicative end of experimentation, I've worked from the statisticians end of experimentation. I think I'm not very well equipped to answer that question, because yes, I've seen very less KPIs for that matter. So by default, I tend to think about conversion rates or revenue. Conversion rates, I think, are good. They can be defined in multiple different ways. But when we talk about continuous metrics, I think things should
Yeah.
get more interesting. But there, I do not have a lot of data, since we only introduced these different sort of metrics 2 3 years ago. So that's somewhere I do not have context. But what do you think? I'm curious to know your answer on that.
Favorite distribution? Do you have any?
I think in the kind of data space that now we are talking about, like sort of, we're talking about anyways very large numbers and no variables are sort of pure. Like when we used to talk about
Yeah.
exponential or Poisson, that was sort of very pure, like purest descriptions of variables, like how many calls are you getting in a minute, sort of like a Poisson thing. I think now things are very much like a lot of these internet variables that we are talking about, they sum up different variables, so a lot of things look normal. Uh, but I think, again, coming back from mediocristan and extremistan, I think there are only two distributions to care about. One is the normal, and the other is the Cauchy distribution. Cauchy distribution is looks like normal, but has such fat tails
Okay.
that it has a lot of outliers and it has no defined variance and no defined mean. So Cauchy, I
I see.
think, represents extremistan for me. So yeah.
Would you say like it's super close to uniform? Like somewhere
No,
between
it is.
normal and
It has a
uniform?
lump in between. It has a
Okay.
the defining factor is, like, compared to the normal distribution, it just has a long fat tail on both sides.
Okay. I see.
So, like, when you actually sample from that distribution, the sample can come from sort of anywhere. The mean does not
Yeah.
converge for Cauchy.
Okay.
So
I
when I
see.
first saw that distribution, I was like, can there be a distribution where the mean does not converge? And it took me probably a few years to realize that yes, and they are all around us. So yeah.
Okay. Nice. Cool.
So yeah.
And one last opinion, like what is one statistical hill that you'll die on? That is, what is one statistical method or concept that you will absolutely defend no matter what others say or others' opinion?
So I have actually a very interesting idea there, and I talked about it briefly. But I think uh, this is something that I really want to work upon eventually in life when I have time and whatever. I think this whole causal discovery is a very difficult problem. You can tell correlation, but you cannot tell causation among variables, Whereas what I feel that something that the entire scientific and statistical community has missed out is that noise is an amazing thing to figure out if X causes Y or not. And I'll explain that with an example. So suppose if you are a publisher and you are publishing a, say, a copy of a classic, and you are concerned that maybe 10 years later you'll run into some copy or some first hand copy or something, and you want to be able to prove in copywriting code that this copy has been derived out of my book and not from someone else's book. The what copywriters have been doing is that they introduce spelling errors somewhere randomly in the text, like somewhere on page 37 or something you'll have a spelling error in some specific word. And once, so if they run into a copy somewhere maybe years down the line, what they do is they use this as the proof that, see, on page 37 there was this spelling error that was specifically there in our copy as well. So if that copy has been blindly copied, it can prove the direct causal link.
Mhm.
I think this idea is very underexplored. Like, for instance, in experimentation, if I think about it, what I personally feel is that suppose you want to establish if the color of a button, or the, say, for simplicity, if the hue of a button is impacting the conversion rates or not. One very powerful idea that I feel has not yet been tried, which will sort of be easier than experimentation, is like, rather than running an experiment, if you sort of add a random noise to that hue, that
Mhm.
sporadically for some visitors you add sort of like big blips to the hue or subtractions. And if you try to see that if the same fingerprint where you added this noise can be extracted from the other side as well, did it lead to the exact point where the color hue was high or low? So I
Mm.
think this essentially, whenever X causes Y, whatever is the noise fingerprint on X get transferred to Y. And I think this is somewhere I we do need the maths for it also. I worked on it for some time, but not in detail. But I think this is a very underexplored idea, which I really want to crack in the coming years. And yeah, I would want to die defending. So yeah.
You are giving ideas to button testers, man.
Yeah.
Yeah. So we are saying that we are still
And
not done with button color tests. Uh,
I was just taking an example, but our button testers like sort of look down upon in
yeah, yeah.
this.
I'm just joking, but yeah, definitely fascinating about about that specific idea, introducing noise and then uh, correlating or identifying causation down the line. I'm pretty sure there might be some work out there about this idea,
I
and
think
how
it
we can
is.
use for experimentation is a
Yeah.
different question. But yeah, makes sense.
Yeah.
So it was great talking to you. I think I have just all these questions mostly.
Yeah.
Before we go, where can the listeners or viewers learn more about your work, stay updated with your insights about your writing that you are pursuing in terms of copywriting, or even, I guess, educational content, right? So this is your time. Like, just let everyone know about you more so that they can follow you.
Thank you. Thanks a lot for the opportunity. So, firstly, I'm writing regularly on LinkedIn, and I'm sharing a lot of my ideas in statistics and experimentation on LinkedIn. Every Tuesday, I'm also doing webinars. I've done 9 up till now. The 10th one is scheduled for the next
Okay.
Tuesday, where I'm teaching different topics around experimentation statistics. I plan to launch a course in experimentation targeted at people who are leading experimentation teams and basically want to understand the background of statistics in experimentation and how it impacts. So that is one thing where I would be actually sharing most of what I've learned in the past 4 years and the broader perspective and experimentation I've gained. Apart from that, I think LinkedIn is definitely the best place. I am planning to come up with some new uh, places. Some of my ideas can be read on the VW stats blog, but I'm not writing that actively now. So I'm probably, as I get more time, I'll start writing on a blog and I'll share with users.
But
So
that
for
won't
now,
be
I would
on
still
VWO,
assign.
right?
I'm
That
sorry.
won't be your future blogs won't be on the VWO blog, right? It would
No,
be
the
on
future
your.
blogs will not be on VW. I'm planning
Okay,
maybe. Yeah, I'm
your
still
own.
figuring it out. So yeah.
Okay, okay, cool. All right. So, do you have anything else?
Yeah, no, I think I'm good to go. It was an amazing
All right.
conversation, and yeah, some really amazing questions that you prepared. I really like the rapid fire round. So
Yeah, yeah.
thank you for yeah.
Yeah, and I was hoping to be just rapid fire, but it was good to actually get details about why that choice. All right, so I think that's it for the episode. And go check out Ishan's profile, follow him on LinkedIn, connect with him. There is also a bell icon on LinkedIn if you did not know, just like on YouTube. So either ways, this video will be on YouTube. So definitely hit the bell icon on YouTube. I will have probably more podcasts coming soon from the experimentation practitioners and data scientists as well. And obviously go to my profile and follow me if you are not already following. There is a bell icon over there as well. Hit that so that you are notified about all of our posts. But yeah, so that's it for this episode, and thank you, Ishan, for making it a special one, because this is also an episode number 1 of the podcast. All right.